The function f of x equals 5x plus 8 times e to the negative 6 power. E to the negative 6x power has one critical number. Find it. All right, so critical numbers occur whenever the first derivative is equal to 0 or the first derivative is undefined. So we need to check both of these possibilities. There could be an undefined first derivative here. Let's see what happens. So the first derivative, thing you want to make sure you pay attention to is there are two parts to this function that are separately of x and multiplied together, which means we have to use the product rule to get the derivative. So the product rule says to take the first function times the derivative of the second, so e to the negative 6x. E to the negative 6x is its own derivative, but you complete the chain rule by multiplying by the derivative of the exponent, plus the derivative of 5x plus 8, which is just 5, times the second. So the first times the derivative of the second plus the derivative of the first times the second. All right, we are going to set this to 0 and solve, so it's probably in our best interest to do some simplification if we can. So let's see, this would be like negative 30x minus 48 e to the negative 6x plus 5 e to the negative 6x, which would be e to the negative 6x times negative 30x. So it would be plus 48 here, and there's still a plus 5 there, which would combine to negative 43. Okay, so now what we want to do is set this equal to 0 and solve. So the tricky thing here is this exponential. But if you think about an exponential and its properties, so this is e to the negative 6x, but we'll handle that in a second. This is just regular old y equals e to the x. If I try and, well, let me say what I'm thinking here. I have one item multiplied by another whose product is 0. So what that means is the first term has to be 0 or the second term has to be 0. One of those two things has to be true in order for a product to be 0. So I'm looking to where this function is equal to 0. But look at this exponential graph. Exponential functions never reach 0. They only approach 0. And even if you made this a negative, e to the negative x, all it does is turns this graph around. It doesn't really make it any different. It's still not going to equal 0. So there are no solutions here. So for this particular part, there is no solution. If you want a little bit more analytic way of determining that, think of your logarithms. So with logarithms, what that says is you can solve an exponential equation which has an exponent that's a variable by changing to log form. So it's a log base e, which is a natural log, of this number here, which is equal to negative 6x. Okay, now, it's looking a little bit different, like you could solve for x, but here's the problem. The natural log of 0 is undefined. So that right there tells you, again, there's no solution to that equation. So we turn ourselves to this part right here. This does have a solution. I could, in fact, take the 43 over, so I would have negative 30x equals 43, or x equals negative 43 over 30, which is a bit of a crazy number, but if you're uncertain that that's the case, you could certainly test it out. You look at a graph and see if that makes sense with the graph. But certainly, Just because the number looks random doesn't make it incorrect. So that is the critical number.